I don't know. So here is the first part of the study guide. So let's go through. The nucleus of the atom contains what? What does it contain? Irene? Protons and neutrons. Very good. The number of blank in an atom is always indicated by the atomic number. All right. Protons. Good. How do you calculate the number of neutrons in an atom? Irene? Atomic mass minus atomic number. Okay? Most of the mass of an atom is contained in the what? Irene? Nucleus. Is she the only one that knows the answers? All right, so we got an answer to the right, so I got to clip this one. Hold on. All right, so this is what we're answering about. Okay? So, what is the element? Potassium. Okay? What is the atomic number? 19. What is the atomic mass? 39.098. Now, why is this a decimal? The average atomic mass. Remember I said this the other day. If first graders weigh 40 pounds, does that mean every first grader weighs 40 pounds? No. That means that's the average for first graders. So some first graders weigh more and some first graders weigh less. All right, how many protons does it have? 19. How many electrons? 19. It says about how many neutrons. So we'll say if it's 39, about how many? So that'd be 39 minus 19, which would be 20. Good deal. All right, so let's see if I can scroll this up. All right, if protons have a mass of 1 AMU and neutrons have a mass of 1 AMU, what is the mass number? Why does the mass number have a decimal place? Why is it? Irene? It is an average, that's right, of what? Of all the, what are they called? Isotopes, that's right. It's an average of all the isotopes. Very good. All right, so the next section says draw the Bohr model. So when we talk about the Bohr model, we're worried about the electrons. So how many electrons does carbon have? It has 6 electrons. We're going to do what? 2 in the first, and then how many more? 4, okay? So how many valence electrons does carbon have? 4, that's right. Has 4 in that last shell. All right, boron has atomic number 5. So how many electrons in the first shell? 2, and then how many in the second? 3. So how many valence electrons does boron have? 3 valence electrons. 3 valence electrons. That's 5 total electrons, but 3 valence electrons. All right. Oxygen has 8. So how many go in the first? 2. And how many in the second? 6. 1, 2, 3, 4, 5, 6. All right. So how many valence electrons does oxygen have? 6 valence electrons. Okay. All right. So now we're going to do dot structures. So dot structures are only what? Only the valence electrons, right? Not all the electrons. Okay, so how many valence electrons does chlorine have? 7. Okay, remember we go all the way around. 1, 2, 3, 4, 5, 6, 7. Okay, how about sodium, Na? 1. Okay, how about magnesium? 2. Okay, you do. Remember, you got to go all the way around. You can start either at the top or at the right. It doesn't matter. Okay? How many does oxygen have? 6. So 1, 2, 3, 4, 5, 6. Okay? Any questions on valence electrons, electron dot, or Bohr? All right, so answer the following questions about this isotope. Okay, remember this is one of the first graders that isn't average, right? This is 13. So how many protons does this atom of carbon have? 6. Remember, proton number doesn't change. How many neutrons? 7. It's 13 minus 6, so it's going to be 7. Okay. No, but I'm showing you the equation, so you know how you got it. And also because I'm recording, remember? Yeah. All right, atomic number. What's the atomic number? 6. And what's the mass number? 13. Okay. Remember that the average atomic mass for carbon, I can't see. What does it say? It's 12 point something. What is it? 0108. Remember, that's the what? Average. That's the average. But this is carbon 13, which is an isotope of carbon that is 13, not 12.018. Yeah? If carbon 12 has 6 protons and 6 neutrons, then what would an isotope of carbon have that has 8 neutrons? Okay? Well, 6 plus 8 is what? 14. So what would it be? Carbon 14. Okay, and we would write that one 14 carbon 6. Yeah? So you could either write it like that or like that. But it would be carbon 14. All right, so now let's talk about ions. Okay? An element that gains an electron takes on what? So it gains an electron. What kind of charge? Negative. So this one's going to be negative. Okay? Because it gained electrons. Okay? How about an element that loses electrons? Positive. Okay? And that one's going to be a positive charge. If an ion of an element with an atomic number 30 has a +4 charge, how many electrons would it have? It'd be 30 minus 4, so it would be what? 26. Okay? If an ion of an element with atomic number 30 has a -4 charge, what would it be? Yeah, 30 plus 4, so that one's going to be 34. Yes? All right. How are we doing, guys? Okay, so now let's fill out this chart with all of it together. Ions, isotopes, and atomic mass. So beryllium has an atomic number of 4, so how many protons does it have? 4. It has a mass of 8, so how many neutrons? 8 minus 4 gives you 4, and there's no charge on it, so how many electrons does it have? 4. Okay? All right, so now we have oxygen. Okay, so what's the atomic number for oxygen? Okay, atomic number is 8. What's the mass number? 16. So how many protons? 8. And how many neutrons? 16 minus 8 is 8, and it has no charge, so it has 8 electrons. All right, now we're at nitrogen 14. What is the atomic number for nitrogen? 7, because remember, atomic numbers never change, right? What's the mass? 14. How many protons? 7. How many neutrons? 14 minus 7 is 7, and electrons are already filled in. All right, now we have an ion. Chlorine 1 minus. Y'all see it? All right, so how many protons does it have? 17, because remember, protons don't change. Neutrons would be 35 minus 17. So what's that going to be? 18. That's right. Now, electrons. How many? 18, because we have minus 1. We have 1 extra, so it's 17 plus 1. So that one right there is 17 plus 1 electron. Okay? All right, now we don't know what element it is. How can we find out? Yeah, the number of protons is 9, which makes its atomic number what? 9. So what's the one with atomic number 9? Who's atomic number 9? Fluorine. That's right. So we got fluorine. Okay. All right. So 20 minus 9 for my neutrons. What does that give me? 11. Okay. The electrons are 7, and my atomic number is 9. So did I lose or gain electrons? I lost. How many? 2. So that makes my charge what? 2 plus. Yeah? All right, now we got potassium, big K. So what's the atomic number for potassium? 19, which means my number of protons is also 19. My atomic mass is 40. Okay? So my neutrons is 40 minus 19. What does that give me? 21. Good. And I've got 3 plus for my electrons. So what are my electrons going to be? 19 minus what? 3. So how many? 16. How are we doing? Good? Okay. All right, so magnesium. I got an atomic number of 12, so my number of protons is 12. It's asking me for my mass. How am I going to find my mass? I got protons and neutrons, so 12 plus 12 gives me what? 24. That's right. And then it says it has a 2. Is that 2 plus or 2 minus? 2 plus. So 2 plus means I got what? 12 minus what? 2. So how many electrons do I have? 10. Yep. All right, one more. Atomic number is 17. What has an atomic number 17? Fluorine. Okay. So I have 17 protons. Now, how many neutrons do I have? I got 36 minus 17. So what does that give me? 36 minus 17. What does that give me? How many? 19. Okay, sorry, I didn't hear you. All right, so I got 19. Now I have 16 electrons. So what's my charge going to be?
No.
Just plus, right? Because it's plus 1, right? Because I've lost 1. Okay? All right, so Mendeleev published the first periodic table by arranging the elements in order of increasing what? Atomic mass. That's right. Was he right? No, but he was really close. Moseley came along and rearranged the elements by increasing what? Atomic number. Yeah. Okay? All right, so let's identify each of the following periodic table square: atomic number, average atomic mass, and chemical symbol. All right, where's the atomic number? 7. So that is atomic number. Okay? All right, where is the average atomic mass? On the bottom. That is the average atomic mass. Okay, and where is the chemical symbol? N.
So when your atomic mass has a decimal, that means that.
Okay, it says which letter could be an element with 4 valence electrons? Okay, that's 1, 2, 3, 4. Okay, so which one could it be? J. Good. Which letter is an element with 2 energy levels? That's 1 energy level. That's 2. What's it going to be? I. Good. Which letter is an element with 7? H. Which letter is an element with 8? E. Okay. Which letter is an element with 5 energy levels? D. That's right. Good. Which element blocks labeled would be the most reactive metal? Okay. What 2 elements labeled are transition metals? C and G. Good job. Which of the elements labeled would be a halogen? H. Very good. Very good. Almost there, guys. Almost there. Are y'all making adjustments to your papers? So tiny. Why is it paste so tiny? Like we have supervision. All right. Which side of the table are the metals on? Left or right? Left. Which one is the non-metals? Right. That's right. Now, if I'm doing my thing, this is the left side and this is the right side, right? So make sure you know that, because on the test it might say left or right. And if you don't know left and right, that's going to be a problem, right? What are characteristics of non-metals? They're non-conductive, right? They're brittle. They are gases, some of them at room temperature, right? What else?
Not lustrous.
Yes, and they're dull, meaning not sharp but not shiny. Okay, what are some characteristics of metals? Yes, they are shiny, which means they have what? Luster. Okay, and they are conductive, meaning they conduct what? Heat and electricity. Okay, they're malleable. What does that mean? Remember, they can be shaped into different things. That's why we use them for jewelry. They're ductile, which means what? Shaped into wires, right? They have high melting points. All of this is in your PowerPoint if you need to go back and look at it. Groups and families are vertical columns of elements with similar properties, including valence electrons. That is definitely true. Periods and rows are horizontal, that tell you how many energy levels an element has. That should be an element has. I don't know what happened there. Which family is the least reactive? Noble gases. Why? Why? Valence shell is what? Already full. Yeah, valence shell, or you could say outer shell. Fine too, right? Already full. Okay, so which way does it increase? Atomic mass, which way does it increase? Yeah, increases this way. And what other way? Yes, increasing left and down. Okay, how about atomic radii? Which way does it increase? It goes which way? This way and this way, right? So where are the biggest atomic masses? Where would the largest atomic masses be? Right here. Where would the biggest atomic radii be? Yeah, because remember, these hold those electrons super tight, right? Super tight. Hold those electrons really, really tight. All right. Let's look at reactivity and the last three. Are those big? Can you see it? All right, where are you most metallic? Or let's do reactivity. Where are the most reactive ones? We did atomic radius.
Is it reactivity electronegativity or?
All right, well, let's do reactivity and then we'll do electronegativity too. All right, so reactivity, remember for metals, where are the most reactive metals? It goes this way and this way. For non-metals, which way does it go?
Right.
Yeah, this way and this way. So the most reactive non-metals would be here, not including this one, right? So right here. And the most reactive metals would be where? There, right? All right, so metallic character. When you are more metallic, which way are you? This way, right? So more metallic goes this way and this way. So the most metallic would be here, right? All right, so ionization energy. Ionization energy. That means it's hard to take the electron. So where is the hardest ones to take the electron from? Yeah, the hardest ones are going to be where? Right there, right? Because remember, they hold on really tight. And then the last one you said you had was electronegativity. Yes? Okay. So let me grab a periodic. Where am I most electronegative? That means it has more electrons. So where would it be? It increases going this way and this way. So my most electronegative would be where? Right there. So this is more what? More electrons.